All right, so this is probably one of the most important reviews that we're going to do, and this is on factoring. So you are going to factor a lot in this class and a lot in calculus. So big review on this. So first thing you should always do is see if you can pull out the greatest common factor. So you would use this for any number of terms. And it's always the first thing to check. So you want to see if there's a greatest common factor, always. That's the first thing. And it doesn't matter if you see something else, that's what we always want to do. Okay, now for two terms, we have a couple of different options. We can have the difference of squares, and then also with two terms, you have the difference or the sum of cubes. So difference of squares, difference or sum of cubes. So those are the two things to look at when you only have two terms. And what this means by two terms, if I had something like x squared plus 121. So I only have two terms. I have the x squared term and I have the 121 term. So only two things here. Now, if I have three terms, that would be like if I added in a 3x in there. So if I have three terms, what we're always going to do with a three-term function is we're going to do the guess and check method. And I call it guess and check. Some people call this trial and error. And it is the easiest way to figure this out. What we don't want to do, there's a lot of gimmicky ways to try to solve this, but we want to just do guess and check or trial and error, depending on whichever term you're most familiar with. And I'm going to give you some tips as we go through this today. And then for terms, we always want to do grouping on this. So we're going to break it out. And grouping is going to be something where we end up with two multiple terms, and then we're going to use a greatest common factor to pull something out. Okay? So let's practice this a little bit. Hopefully it all comes back to you quickly. So common factor. So when we pull something out with a common factor, this is like the opposite of distribution. So let's look at this for a minute. So if I have 3 times x plus 4, when I distribute this, I end up with 3x plus 12. So when you factor, this is what we're going to see, 3x plus 12. And what we want when we factor is we want to go this way. So when we go this way, we call it factoring. When we go this way, we call it distribution. So we're distributing. Okay, so these two things are just opposites of each other. All right, so what we're going to do when we look at this is we're going to look at, first of all, the coefficient. So I have three terms here. And remember, first thing's always common factors. So I'm going to look at the coefficient and I'm going to say, what is the biggest number that I can pull out? Well, these are all multiples of 5, but I can't pull out anything bigger than a 5. So I'm going to do this the long way first, and then you're going to see a shorter way to do this. So it's like dividing by 5, dividing by 5, and dividing by 5. Okay? Now I have to look at the rest of this. I'm going to look at the variables. Now in this case, I only have one variable, just an a. So I have 7 a's here, 4 a's here, and 2 a's here. So the largest quantity I can pull out are going to be 2 a's. So I'm going to divide this by 2 a's, divide this by 2 a's, and divide this by a squared. So 2 a's again. Okay, now what I'm doing, my greatest common factor is 5a squared. That's what I can pull out of every one of these terms. Now I'm going to use my factor, or I'm going to use my exponent rules, and I'm going to divide this. So if I divide this, I end up with 2a to the 5th. And this middle term here, I end up with a squared. And this last term here, I end up with minus 4. Okay, so my signs are staying, and when I divide this out, I get a negative 4, and I have a squared and a squared. So this is my factored form with my greatest common factor. And you've got to have the 5a squared. You have to keep that part out. Okay? So now I look at this one. So my base here is a y, so that's the only thing I can do is pull out a y, and I want to find the biggest y I can pull out. Well, the biggest y I can pull out is going to be a 1/2. 1/2 is smaller than 1.5, which is smaller than 2. So what I'm going to pull out is y to the 1/2, and then that tells me what's left. If I pulled 1/2 out, then what's left here is 3/2. And if I multiply this out, you'd see that's 4 over 2, which is 2. With this one, I'm left with 1y, and with this one, I pulled the whole thing out front, So it doesn't go away. I have to leave the plus 1. And the thing is if I was to check this by distributing, I have to have this plus 1 to get this last term right here. Okay? So you can always check these just by distribution. Okay? Now with this one, I could go ahead and FOIL it out and see what I can pull out. But if I look at this, I have a 2 and I have a 6. So I know I can pull out a 2, right? X and Y, I can't do anything here. But this X minus Y, that is actually a factor because the whole thing is in parentheses. So I'm going to pull out a 2, X minus Y. Okay? And what's left when I do this, I'm going to use parentheses here. What's left when I do this, I pulled out the 2 right here, and I pulled out the X minus Y. So in this form, I'm only left with the X. And if I look over here, I pulled out a 2, so I'm left with a 3. I didn't pull out the Y, so the Y is still there. And then I pulled out the X minus Y. So this is what is left. Okay? All right. So if we have two terms, the most common thing that we're going to look at is the difference, difference of squares. Okay, now when I have a difference of squares, what this is going to look like is just like this. So if I have x squared minus 121. Now the key here is this misspelled word difference, and difference means subtraction. So here I have two terms. I can take the square root of this term, and I can take the square root of this term, and I'm subtracting. So I can use difference of squares. So if I took the square root of this, I would have x. So I start with x in both of those. If I took the square root of this, of 121, I have 11. Now, when I have a difference of squares, this means that one is positive and one is negative. So one term is positive and one term is negative. And this is my factored form using difference of squares. Now, the reason I have to do this is because if I was to FOIL this out, and I FOIL this middle term right here, I would have a positive 11x. And if I FOIL this outer term right here, I would have a negative 11x. So what happens is this middle term cancels out. And when the middle term cancels out, we don't have a middle term here. So I have to have one that's positive and one that's negative. Okay? I'm doing the same thing here. I can take the square root of both of these. So I have 6 plus a and 6 minus a. Square root of 36 is 6. Square root of a is just a. And what you'll notice is that in this case I have this is plus and this is minus, but you can flop these around. You can have 6 minus a and 6 plus a. Okay? What you do have to do though is the a is the second term. So because the a is the second term, when I FOIL these two, I would get a negative a squared, which is what I have, negative a squared. So the order matters. In this case, the x was first, and that's why the x is first in my factored form. Here, the constant, the 36 is first, and so that the 6 has to be first. Okay? Now, don't let it jam you up if it's not letters. So I can take the square root of p, and I can take the square root of q, so I would have p plus q and p minus q. Okay? Now, in this case, this is a difference of squares. I can take the square root of this first term, and I can take the square root of the second term because it's squared. So my first term is going to be a plus b, and then that's going to be times x plus y. Now this whole thing is my first term. Oh, I forgot my plus in there, sorry. And then I do the second one right here, which is going to be a plus b minus x plus y. So this is the one that's positive, and this is the one that's negative. Okay, last one. Square root of this. So my first term is 5x squared. The second term here is plus 7y. And this is 5x squared minus 7y. So why is it 5x squared? Well, when I take the square root of this, so the square root of 25x to the fourth, right? My constant becomes a 5, but I can pull out x squared. It's not just an x. So that's why I have x squared. Okay, now I want to show you something really quick. So all of these are differences of squares. Okay, so difference of squares is super important because we have one term that's positive and one term that's negative. But what happens if I have this? X squared plus 121. Well, I can take the square root of this, and I can take the square root of this, right? However, if I did this, there's not a way for me to make them both positive, because then I would have a middle term. So if I did this, x plus 11, well, this would give me a positive 121. But when I FOIL this out, oops, I'm going to go the last term and these middle terms, I would have 11x plus 11x, so I would have this middle term of 22x, right? When I FOIL this, I would have a middle term of 22x, and I don't have that. So what this is called a sum of squares. And here's the key about sum of squares. It is prime. And if you remember what prime means, that means it cannot be factored. Okay, so super important, just because you see that they are both a number that you can take the square root of. If you're adding, it's a sum, and a sum of squares cannot be solved, right? Cannot be factored, so it's prime. Now, what you're going to find is that we do have a solution for this. There is an answer. It's going to give us an imaginary answer, and we're going to deal with that later on. But it's prime in terms of that it can't be factored. Okay? All right, let's flip it over. So we're still on two terms here. So the other thing that we want to cover when we're doing two terms are the sum or difference of cubes. So what this would look like is something like this. This is cubed, and this is cubed. I can take the cubed root of 27, and I know that the cubed root of 27 is 3. Okay? Now, here's what's different. I can't just do x plus 3, x minus 3, because that wouldn't give me enough numbers. So a lot of times, and you might have heard this as a little acronym to remember this, same, opposite, always positive. So when we see a sum or difference of cubes, we sometimes use this acronym of SOAP, and it stands for same, opposite, always positive. And it's a little hokey, but I'll show you what that means. So if I took the square root of this, I would have an x. And if I took the square root of this, I would have a 3. Okay? Now, when I do that, I'm going to use the same sign. So this is addition. So I'm going to use my same sign of addition. Now, what I'm left with now is a trinomial. So my trinomial, remember my two values were x and 3. So if I have x, this has to be x squared. Now I'm going to multiply the two together, and I would have 3x. And I square the last term, and I would have 9. So first term squared, two terms multiplied together give me the second. Last term squared gives me 9. So if I go back to my SOAP, this was my same sign. So if this is addition, this is addition. The opposite sign goes next. So my opposite sign is going to be a negative. Opposite of positive is negative. And the last term is always positive. Okay? So all this does is it helps you with your signs. So let's try another one. So this is cubed, and this is cubed. So when I cube this, what I end up with is 4a, and what I end up here with is 5m. It's not the square root, it's the cube root. So you're looking at the cubed root of 64, which is 4, and the cubed root of 125, which is 5. Okay? So if I have 4a and 5m, that's going to be the first part. And now I square the first term, so I have 16a squared. I multiply these two terms together, so this is 20am, and then I square the last term, which is 25m squared. Okay, now I go in and put my signs. So same sign, so this is negative, opposite sign, always positive. And then this is my factored form here. All right. So next thing we have are things with 3 terms. So first thing you always want to do is see if we have, so find a GCF. Always pull out a GCF first. Then the second thing that we're going to do is we're going to do guess and check. And as I mentioned on the other side, depending on where you're coming from, you might use the term trial and error. But trial and error and guess and check are still kind of the same thing. Okay? All right. So what are we going to do? The first thing that we're going to do is we're going to break this into, so break it into 2 sets. So we're going to have something that looks like this. We're going to break it into 2 sets. Okay? So the next thing we have to do is we have to evaluate the signs. And when we do this, we know that we're going to have one that's positive and one that's negative, or both that are positive, or both that are negative, but we have to evaluate the signs, okay? And this is based on the last term. All right, so here's what happens. If I have something like let's see, I'm just going to write something down. So x squared plus 3x minus 4. If I have something like this, because this last term is negative, I know that I have to have something where one of my factors is positive and one of my factors is negative. If this was plus 4, then I can have both of my factors can be positive or both of my factors can be negative. So we're going to evaluate the signs based on the last term to decide what signs am I going to put in my 2 factors. Okay? So then we're going to place the first term in each of the parentheses, and then we're going to put the last term in each of the parentheses, and then we're going to check the inner and the outer of FOIL. So I guess I could have done these the other way. But we're going to check. We're going to FOIL it, outer and inner, and we're going to see if it makes sense. Okay? So let's try this. If I look at my factors of 6, my factors of 6 are 1 and 6 and 2 and 3. If I look at my factors of 12, I have 1 and 12, 2 and 6, 3 and 4. Okay? Now, let's go back up here to helpful hints. So what I want to do when I look at my factors of these is I want to start with the factors that are closest in number. All right, so what this means, if I look at this, 2 and 3 are closest and 3 and 4 are closest. The majority of the time, this is what works. Okay, so if I do this, I put my parentheses here, I see that this is positive. So if it's positive, I know that they're either going to both be positive or both be negative. Well, since my middle term is positive, then I'm going to use this term, where they're both positive. If this was negative, I would have to use the negatives. Okay? So if I use my middle ones, I'm going to have 2x here, I'm going to have 3x here, and then I'm going to use 3 and 4. And when I FOIL this, I want to see if I equals up to 17. So if I put a 4 here, that's going to give me 12. If I put a 3 here, that's going to give me 6. So 12 plus 6. So that's going to be too big, so I'm going to mix them up. So if I put a 3 here, this is going to give me 9. And if I put a 4 here, it's going to give me 8. I'm going to add these up. So I would have 9x on the inside, and I would have 8x on the outside. When I add this up, it gives me 17. So those are my 2 factors. Okay, let me try another one. If I look at this one, my factors are going to be 1 and 5, and my closest 2 factors here are going to be 2 and 5, because 2 and 5 are going to be closer than 1 and 10. So I'm going to have x and 5x, and the other 2 numbers I'm going to use are 2 and 5. Okay, well, I see here that this is negative, so I'm going to have 1 factor that's positive and 1 factor that's negative. So when I do this, I see that I have a 23. So right away, what you should see is that this is going to give me 25, and this is going to give me 2. So 25 minus 2 is going to give me 23. So that means this has to be positive, because when I FOIL it, I get a positive 25. And this has to be negative, because when I FOIL this, I'm going to get a -2, which gives me a positive 23, which is what I have. Okay, let me do one more. So if I look at the two middle terms that I have here, it's going to be 3 and 6. Now remember, I could have used 1 and 18, I could have used 2 and 9, but when I'm doing guess and check, I want to find the ones that are closest together. Same thing here. I want to try to use 3 and 4. Maybe it won't work. I might have to go back and do 2 and 6. It's negative, so I'm going to have one positive, one negative. This is negative, so my bigger number is going to be negative. Okay, so I end up with 3x and 6x. I want 19. So if I put a 4 here, it's going to give me 24. And if I put a 3 here, it's going to be 9. So 14 minus 9. So let's see if that works. So this would be 24. And if I put a 3 here, this is going to be 9. So that doesn't work. Okay, so if I mix it up, this is 18, and that's 4. So 18 and 12, that doesn't work. Okay, so I can't do a combination of these that work. So what happens is, now I'm going to go back and I'm going to trade these. So let me try this now. I'm going to decide 2x, I'm going to use these two terms, 2x and 9x. Okay, so if I have 2 and 9, I'm going to do the same thing. So let's say if I put a 3 here, this gives me 27, and if I put a 4 here, it's going to give me 8. If I subtract this, I'm going to get 19. So I know that this is my negative and this is my positive. So here is an example of where my two closer terms, 3 and 6, didn't work. Okay, and that's one of the reasons why we call this trial and error, or guess and check. Okay, I'm going to pause this. I want you to work the next 3 by yourself and then come back and check your answers. Okay, so ironically, we have a bunch of these where our middle terms don't work. So this one, again, we use 9 and 2 instead of 6 and 3. With this one, we had to go to 21 and 1 and not 3 and 7. And with this last one, make sure your x squared term is what's your negative term here. So we have 3 plus 15x, oh sorry, 3 plus 5x and 1 minus 3x. And the reason why I would tell you not to rewrite this as negative 15x squared, it's always tricky when you're starting with one term that's a negative. So this is actually an easier way to look at that. Okay? All right, let's go on to 4 terms. So when we have 4 terms, we have a grouping. And so what happens when we want to group, the first thing that we want to do is we want to put it in standard form. And when you put it in standard form, it would be like ax squared plus bx plus c. So this is descending exponent order. Okay? Then the next thing that we're going to do is we're going to factor, and we're actually going to use a GCF. So GCF, factor each 2 pairs. And then the third step is we're going to actually use the GCF of each pair. Okay, so words, that looks a little funky, so let's just try this. So this is in descending order, x cubed, x squared, x, and constant. So I'm going to break this in half right here, and I'm going to look at just this first part. So all I'm going to do is pull the GCF out of this first pair. So I have my first pair here, my second pair here. So if I pull my GCF out, it's going to be x squared. So I have x squared is my biggest term. I can't pull out any numbers, and I'm left with x plus 3. And I can check this because I can FOIL it. So now I'm going to go over here to the second pair of numbers, and I'm going to pull out a positive 5. And when I pull out a positive 5, I end up with x plus 3. Okay, so I just did number 1, standard form, number 2, factored the GCF out of each pair, and now I'm going to pull the GCF out of each pair. Well, here's my GCF, x plus 3 and x plus 3. So I'm going to factor it again, and I'm going to pull out an x plus 3. And when I do, what's left is this first term, which is x squared, and this second term, which is plus 5. And this is not a difference. It's not a square, so I'm done. Okay, now this next one's a little bit tricky because it's not in standard form. So I'm going to group this as best I can. So these both have B's, and these both have A's. So I think that this is already written in the most factorable form. So if I break this into a first pair, the biggest thing that I can pull out of this is going to be a 2A. I can pull a 2 out of both terms. I can pull an A out of both terms. So I'm left with 3x minus 5. Okay, so now I'm going to go over here. And if I look at this, I can't pull out a number, and I can't pull out an x. All I can pull out is a b. So I'm going to pull out a negative b. And the reason I'm pulling out a negative b really has to do with this factor. If you noticed over here, when I pull out the greatest common factor, what I have to have is I have to have something that's similar in both of my groups. So I had x plus 3, which was my similar term, my new greatest common factor here. Well, if I pull out just a b, I'm going to end up with a positive 5 over here, which is not what I want. So when I pull out the negative, I'm left with 3x on this term. If I distribute this back in, you see where the negative comes. And now I have minus 5. So if I was to distribute this back, this would give me a positive 5b. And what I see is I have 3x minus 5 and 3x minus 5. So that's my new GCF that I'm going to pull out front. Okay, so this is gone and this is gone. And what's left is 2a minus b. Okay, I am going to go ahead and pause this again, and I want you to finish the last 4 on your own, and then I'll talk through them. Okay, let's go through these because these are a little bit harder. So with this first one, it's not a difference of squares. There's only 2 terms, but it's not a difference of squares yet because I can't take the square root of either one of these. So I have to go back to greatest common factor. Actually, I should always start with greatest common factor. Always, always. Should be the first thing you look at. So you plot an 8, and you have x squared minus 4. Now, up above, we would have been done. But what you see here is x squared minus 4. So just because you use one factoring method, don't think you're finished. So we had x squared minus 4, which is a difference of squares, so I can keep going. So I end up with x plus 2 and x minus 2. Okay? Over here, the first thing that I notice is that I can pull out a GCF. I can pull an x out of every term, and they're all even, so I can pull a 2 out of every term, and this is what I end up with. Now, in some cases, you might be done. This might be prime, right? This might not be factorable. Sometimes when we have a trinomial, it's not factorable. But in this case, it is. So my 2 terms here were 3 and 1, and if I use 2 and 9, I end up with a negative 27 plus 2, which is negative 25. So always try to keep going after you pull out a GCF. Okay, this next one's kind of fun. So when I look at this, I can pull this out. So my term here is x squared and x squared because I have 4 of them. It's not just x squared, it's x to the 4th. So I have 2x squareds. And then because this is positive, I know my signs are going to both be negative because this is negative. So negative 9 plus negative 1 is negative 10. But we're not done. So both of these are a difference of squares. And actually, this one is missed quite often because people forget that you can take the square root of 1, that the square root of 1 is equal to 1. So if I take the square root of both of these, I have x plus 3, x minus 3. That takes care of this term. And then here, I can take the square root of x squared and the square root of 1, and I have x plus 1, x minus 1. Okay? Now, with this last one, I have 4 terms, so I have to do grouping. So these are all, it's already written in standard form. So I pull my GCF out of the first half, and then I pull it out of the second half. I see my common term here is x squared minus 4, which is great. So I have x cubed plus 3 which is this, and then I have x squared minus 4. Oh, hey, I just realized I forgot something. So if I have this, x squared minus 4, that's a difference of squares. So x plus 2, x minus 2. But this is actually, it's a sum of cubes. So I can keep going. I didn't realize that. So if I can keep going on this, the cube root of x cubed is x, and the cubed root of 8 is 2. So I have x and 2, and then with this next term, I have x squared, I have 2x, I have 4, and then I have x plus 2, x minus 2. So these two guys come down here, okay? So now what I have to do is I have to do my same, opposite, always positive. So same, opposite, always positive, okay? So what this gives me then is this is my final answer, not the one that I had circled up above, okay?